Welcome learners. This is Dr. T. Gangaram, lecturer in statistics, SVA Government College, Srikalahasti. In this video lecture, we will discuss the properties of numerical operators. First, let us look at the relationship between operators delta and E. By the definition of forward difference operator delta f of x, we know that delta f of x is equal to f of x plus h minus f of x. The definition of shift operator E of f of x is equal to f of x plus h. By using these two equations, substitute equation 2 into equation 1. Instead of f of x plus h, we can use E of f of x. So from 1, delta f of x is equal to E of f of x minus f of x. From this, delta f of x is equal to, by commoning the E from f of x, by commoning f of x, we know that delta f of x is equal to E minus 1 into f of x. This leads to the result delta equal to E minus 1. We can express delta in terms of E as E minus 1, or E is equal to 1 plus delta. This is the first property, first relationship between delta and E. By using this relationship, we can find the missing values in a polynomial or in a difference table. Next, the commutative property. We know that the operators delta and E are satisfies commutative property. That means delta E must be equal to E into delta. Delta E of f of x is equal to, first we expand E of f of x, it shifts one step forwards. So E of f of x is equal to f of x plus h. We know that delta f of x plus h is equal to f of x plus 2h minus f of x plus h. Again, this can be written as E of f of x plus h, and this can be written as the second term E of f of x. By commoning the E, f of x plus h minus f of x, again this is delta f of x. So the operators delta and E satisfies commutative properties. The result is delta E is equal to E into delta. Relationship between nebula and the other operators. We know that by the definition of backward difference operator, nebula is given as f of x minus f of x minus h. Since e power minus 1 f of x is equal to f of x minus h, we substitute f of x minus h in the above form. We get nebula f of x is equal to f of x minus e power minus f of x. By commoning f of x, nebula f of x is equal to 1 minus e power minus 1 f of x. The key identities are nebula is equal to 1 minus e power minus 1, or from this 1 minus 1 by e, from this e minus 1 by e. This is equal to nebula is equal to delta by e, or this implies delta equal to nebula into e. This delta is equal to e multiplies nebula, or e is equal to delta by nebula. This is the property relationship between E, delta and nebula. The operators E and delta satisfy basic algebraic laws. Next, the commutativity with respect to constants is, if C is a constant, delta of C of f of x can be written as C into delta f of x, and E of C of f of x can be written as C into E of f of x. Now let us look at the distributive law. delta of f of x plus h is equal to delta f of x plus delta g of x. Similarly, e of f of x plus g of x can be written as e of f of x and plus e of g of x. These are distributive laws. Next, the operators satisfy linearity property also. For constant a and b, we can written as delta a f of x plus b of g of x, a into delta f of x plus b into delta g of x. This is called linearity property of numerical operators. Finally, the law of indices. Operators e and delta satisfy the law of indices. That means e power n into e power m into e power n f of x can be written as e power m plus n f of x. The proof here, first we expand e power n f of x, this equal to f of x plus nh. Again apply e power m here, already f of n plus h is there, it shifts m times, e shifts m times, so f of nh plus mh, commoning h here, f of x plus m plus n into h. This is the shifting, m plus n shift. So we can write this as e power m plus n into f of x. Similarly, we can show delta power m into delta power n f of x is equal to delta power m plus n into f of x. Now, generalized expansion of delta power m into delta power n. By using the relationship delta is equal to e power minus 1, we substitute e power minus 1 in place of delta. So, delta power n m delta power n f of x is equal to e power e minus 1 power m e minus 1 power n into f of x. From this, by commoning e power e minus 1 m plus 1 f of x. By using the binomial expression, we expand e minus 1 power m plus n as summation r is equal to 0 to m plus 1 minus 1. Here minus 1, we need to keep the coefficient minus 1. Alternatively, minus 1 comes m plus n cr e power m plus n minus r. We can understand this by using the expressions. E power m plus 1 minus 1 is the coefficient is minus of m plus 1 c1, and the coefficient of e power m plus n minus 2 is m plus n c2. Similarly, the coefficient of e power m plus n minus r we can written as m plus n cr. From this, we can write delta power m into delta power n is equal to delta power m plus n. Here, the coefficient of m plus n in shifting operator is m plus n c r. So, these are the properties of delta, nebula, and E. Thank you.